So this is 1.4. We're going to talk about reflecting graphs today. Okay, and you have already done this, so this should be a review. We're just going to kind of kick it up a notch. All right, this is what causes a reflection. If you have negative f of x, it reflects it, the graph over the x-axis. So the distance to the x-axis is going to be the same. If it was above, it's going to be below. If it was below, it's going to be above. Okay, so you basically flip it upside down, right? And then if you make the x negative, that reflects it over the y-axis. Had you all seen that before? That's not new, right? That's supposed to not be new. You're supposed to have seen that. Okay, so here we go. We're going to graph the following equations. Part A. Part B, you're going to describe the translation of the original function from its parent graph. Okay? And then part C, we're going to describe the reflection, then what we're going to sketch. Okay, so first of all, let's sketch this. Now, what they're asking in part B, let's do that. We do this all the time. Okay, first of all, this is a what? What's the graph going to be? If there's no squared and no absolute values, what's it going to be? A line, right? I guess it's given right there. Shifted which way? 1. Okay, so that's what I'm wanting you to put here in B. Left 1, which way 2? Down 2. So we're going to go left 1, down 2. So when it says describe the translation of the original function from the parent graph, that's this shift right here, left 1, down 2. Okay, so we're going to sketch that first. So normally we would have started at 0, 0, go left 1, down 2. We'd plot that point, and then with lines, what's the next thing we look at? The slope, right? And the slope here is 3. So we're going to go up 3, over 1, and we just keep doing that same slope, right? Lines grow at the same rate, so we just keep doing that same pattern. Sketch that, and then call that f of x. Got it? Then we're going to graph this, negative f of x. Now, if you don't remember, do you know that f of x is the same as y? Do you remember that from your Math 1 days? Maybe even before that. It's the same as y. If you switch the sign of the y, where y was positive becomes negative, where y was negative becomes positive, that flips over the x-axis. So it ends up kind of being the opposite. If you switch the sign of the y, it flips over the x-axis. If you change the sign of x, it flips over the y-axis. That's how I remember it. Okay, it's the opposite one. Okay, so if we're going to flip this over about, we're going to reflect it about the x-axis. That's what you're supposed to put in part C. So we'll just write reflect about, that says about the x-axis. Reflect about the x-axis, or reflect over the x-axis. Which means that all the points you graphed there should be the same distance, just on the other side of the x-axis. So as I look at this distance is 1 from the x-axis above. I'm going to put it 1 below. And this one here was how much above? 4 above. I'm going to go 4 below. And this point down here was 2 below. I'm going to go 2 above. And then sketch that line. And call it negative f of x. We reflected it about the x-axis, or over the x-axis. The slope of our original f of x is 3, right? What's the slope of negative f of x? If I go from this point to this point, what's that slope? Negative 3. Do you think that will always be the case? Okay. Not necessarily? Okay, we'll see. All right, let's continue with linear. Let's go straight down here. Let's do this reflection now, okay? A little different line. But the first part here that you're doing in part B is, how has this line been translated from the original function? Which way 5? Right 5. And that's it, yeah? Not up or down any? There's no vertical shift? Okay, so we're going to go right 5 from 0, 0. That point's over here. Then we're going to look at the slope, and since it's negative 1/2, we're going to go down 1 over 2, right? And I'm going to go the opposite way. Kind of get this sketch, draw that line, label it, f of x. Okay, so that's the first part. Then we're going to look at this and determine what kind of reflection that is. Since the x has been changed, that's going to reflect over which axis? The y. So reflect over the y-axis. Okay, so the y is the vertical axis. So if it is, it needs to be the same distance, just on the other side of the y. So as I look at this, since this right here is 1 away from the y, I'm going to graph 1 in the other direction. Okay, this point right here is 3 away, so I'm going to go 3 in the other direction. And this one was 1, 2, 3, 4, 5. It's going to go over here. And call that f of negative x. That one actually looks like it has a positive 1/2 slope, huh? This one. So it did in that case changed it. Huh, interesting. I don't know, we'll look for patterns. Won't make any rule yet. That's for lines. Okay, 1 I totally have this, 4 I totally don't. Can you tell me where you're at, please? I want to see. Okay, let's go then to quadratics. All right, for this first one here, quadratic, shifted how? What is that -3 if it's not in parentheses? Which way is it? Down 3. Okay, so we're going to go down 3. And let's see, Amani, can you tell me, does the quadratic usually start at 0, 0, or does it start at 0, 1? 0, 1, you guys agree? Quadratic starts? No? Exponential starts at 0, 1, right? Okay, so this one's 0, 0. All right, so we're starting at 0, 0, and then we're going to go down 3. 1, 2, 3. I'm going to plot that. Okay, and then the next thing I look at is this a value, and the shortcut for this is, in this case it's going to be down because it's negative, right? So down 2 over 1, down a over 1. So I'm going to go down 2 over 1. That only gives me the next 2 points, just on either side of the vertex. That's it. Can't continue that pattern, right? But that's all I really need. Got my upside down U. And I'm going to label that F. Not F, G, yeah. Thank you. Okay, and then I'm going to look at my reflection here. If the negative is out in front of the g of x, how's that going to reflect it? Which axis? Okay, so it's going to reflect over the x-axis. It's okay if I switch that to over instead of about. Okay, so x-axis is this axis, right? It's going to reflect it over that. So where this was down below, it's now going to flip up to above. So I'm going to go up 3, and then from here, plot each of these points. It's going to open up. And I'm going to title that negative g of x. Okay? Let's do this one here. All right, first step, part B. Shifted how? Let's see, Christina, can you tell me if the +2 is in parentheses, which way this should shift? Left 2, you guys agree? Yeah, okay. And normally this starts at 0, 0. So I'm going to go left 2, plot it right here. What's the number that's in front here of this? What's my A value? A 1, right? And I can do just the next 2 points I can do. Since it's positive, I'm going to go up 1 over 1, up 1 over 1. I know it's opening like this, and it's going to be U. Might have been good to know what was happening at 0. Right here on the y-axis, if I plugged in 0, 0 plus 2 squared. So I'd be at 4. 1, 2. It looks like I did a pretty good job sketching that. It would have been right here. Might be good to know that because of how we're going to reflect this. Yeah. What type of reflection if the x is negative? If it's g of negative x. If we're switching the x signs. We're going to reflect over the y, right? It's the opposite. So if I'm going over the y-axis, then I need the distance. It's going to flip to the other side. Those distances need to be the same. Oh, I need to label this. This was G. Okay, label that G. Okay, and now I'm going to make these distances the same. Where this was 1 away to the left, it's going to be 1 to the right, 2 to the left, becomes 2 to the right. What about this point that was on the y-axis? It's going to stay there, right? Okay, so this is still going to go through that same point. Kind of cool. And this is G of negative x. So we had a couple of you that were at 3s. How are you feeling now with this? The reflection thing a little bit better? Okay. All right, let's go to absolute value. I think I just want to do one of these because I feel like we're pretty good with absolute value. So Ryan, I'm going to let you pick. Do you want to do the first one or the second one? Second. Okay, so we're just going to do the second one. So let's graph this first. Vinny, tell me, which way am I going to shift this if it's x minus 4 inside the absolute values? To the right, yeah. So I'm going to write that here first. I'm going to go right 4. Now, does the absolute value usually start at 0, 0 or at 0, 1? 0, 1, you guys agree? Start at 0, 1? No? Starts at 0, 0. What's the only one that starts at 0, 1? Exponential, yeah. Okay, so we're going to start at 0, 0. We're going to move this right 4. So it's going to be right there. Okay, and then with exponential, not exponential, with absolute value, just like with linear, we look at the slope, except it's going to be a V, right? So since it's positive, that means it's opening how? Up. So we're going to go up 2 and then right 3, and then we're also going to go up 2 and left 3, because we're going to make a V. Go a couple more here. And I'm going to call that H of x. Okay, and then we're going to do this reflection. If it's H of negative x, how's that going to reflect? Over which axis? Okay, we'll reflect over the y, which is the vertical axis here. So anything to the right is now going to move over to the left, and you got to keep that distance the same. So this guy's 1 away, so I'm going to move him 1 away this way. This was 3 away. Move him over. Wait, that was 4 away, wasn't it? Shoot, that one's supposed to be right there. Also could kind of do the slope here. I have an extra floating dot that we'll ignore. Okay, and then call that H of negative x. Okay. With those 3, 1 I totally have it, 3 I totally don't. Please tell me where you are. Okay, I want to see. Can you show me your drawing? You good? You good? Reflecting okay? Yeah? Okay. All right, then exponential is probably the trickiest of them because it's the only one that doesn't start at 0, 0, okay? Let's start with this first one. All right, let's see. Let's go. Adrian, can you tell me which way 3, which way 1?
Right 3, up 1.
Right 3, up 1. Okay, so we know we're going to take some point, we're going to move it. Now, this is the one that's special, right? This does not start at 0, 0. This starts right here. So I always put my pencil right there. And then I'm going to move that point, right 3, up 1. And I'm going to plot that because that is a significant point. That's our starting point. Where was the asymptote always in relation to that starting point? 1 below it, right? And it's here at y equals 1, which we also could see that's your vertical shift. Yeah? Okay, then I know this is going to grow exponentially. How did I find that next point? If my base was 2, how did I find that next one? What did I do? It's going to be up 1 over 1, right? It's always 1 less than the base. But say you got to the test and you're like, I don't remember. Just plug in the next one over. What's the x-coordinate here? 3. Plug in 4, and you'll always get a nice, easy value for that. Just go 1 over. All right, but it's up 1 over 1. It's that base just 1 minus the base. And then this shoots up forever and ever, and it comes down here and it gets closer and closer and closer to this asymptote without ever hitting it. All right, so that's J. All right, Emily, can you tell me what kind of reflection this is going to be if it's negative J of x?
Over the x-axis.
Okay, which is the horizontal axis here. So everything that was above is now going to go below. Do you think the asymptote's going to move? Yeah, it moves. Okay, so if it was up here above, it's now going to be down here. This point right here was 2 above, it's now going to go 2 below. And this way, so it's going to flip this whole thing upside down. And that would be negative J of x. Okay. And let's do the last one here. Okay. We ready? Ricardo, can you tell me what kind of shift this would be if the minus 4 is not up to the left? You guys agree? Left 4? What do you think it is? Down. You guys agree? Is it down 4? Okay, yeah, so if it's not up, in this case the parentheses is kind of up in the power with the x, so it would either be an up or a down, and vertical shift goes the same way, right? This would be a down 4. Okay. Now again, what point are we shifting down for? 0, 1. So I'm going to put my pencil right at 0, 1, and then I'm going to take that point and move it down 4. That's a significant point. That's our starting point. Asymptote 1 below it. It's going to be at y equals negative 4, which is that right there. Okay, and then I know it grows exponentially. My next point, since my base is 3, I'm going to go up 2 over 1, right? So up 2 over 1 is 1 less than the base. But again, don't panic. If you can't remember that, just plug in the next point over. Plug in 1. You get 3 minus 4, you get negative 1, you got that point. Easy. You can always plug in if you don't remember all these little rules. Okay, shoots up exponentially, call that J. All right. Liberty Ann, can you tell me what kind of a reflection this is if the x is negative? Which way are we going to reflect? It's going to reflect over which one? Y-axis, yeah. Okay, so you're going to flip it over the y-axis. Anything to the right is going to move over to the left. You've got to keep that distance the same. So this is going to move over here. What about if it's right on the y-axis again? What do we do in that case? Just left it there, right? So this is actually going to come down this way. And call that J of negative x. Okay, so that's the first part you're going to be sketching. Can you flip over to the back side? Directions here, given f below. So this is f. These are solid dots, by the way. Okay. Graph the following and then state their domain and ranges. So this graph is given. Let's find the domain. Domain x values or y values? X. X is left and right. How far left does this graph go? How far right? Are there any holes in the middle? Okay. So it looks to me like this is the furthest left. I can't read those numbers, but what is it? Negative 5. Does it hit negative 5? Yes, there's a solid dot there. So what do I put? Bracket. Okay, comma. No holes in between here. There's no holes on this graph at all. Okay, this is where it stops. How far is that to the right? 3. And it hits it, right? So bracket. Range is the y values. That's how low, how high. I feel like this is the lowest point here. What's the y value there? Negative 4. Does it hit it? Yeah. And then the highest y value looks like it stops right here, yeah? Is this the highest? What is that? 0. Okay, so now what we're going to do is we're going to sketch each of these things. Now this is f, okay? This is fx. We don't know what the equation of it is, although eventually we're going to be able to write that equation. But we don't know it right now. This is telling us f of, it's in parentheses x minus 3, and then outside the parentheses plus 4. So you're going to shift f, which way 3? right 3, up 4. That's what this means. You're going to go right 3, up 4. And so what you want to do is I would take the points that you can obviously see and move them right 3, up 4. So let's start with this one. If I move this point right here, right 3, and then up 4, it looks to me like it ends at -2, 1. I'm going to find that. I'm going to plot that on this point, this graph right here. So I've moved that point right 3, up 4. Okay, and then this is all straight to here. So let's just figure out where this one is. Okay, right 3, up 4. Looks to me like it's at 1, 4. And then since this was a straight line, just do the same thing. Just draw a straight line right there. Okay, this then is curved until it gets to here. So I'm going to plot this one, and then I'm just going to make the curve. Okay, so this one needs to go right 3, up 4. So it looks to me like it's at 3, 2. And then make that little curve. So now we're right here. So then the next thing, since this is just straight down, I'm going to move this guy. This guy down here goes right 3, up 4. It's right here at 5, 0. Straight there, just went straight there. And then this last one is just up 1 over 1. Plot it. Got it. Okay, now let's find the domain of this. Cassidy, can you tell me what my furthest to the left x value is? -2. And it hits it, right? And then what's furthest to the right? 6. Okay, my range, what's my lowest y? Erica, what's my lowest y? 0, and it hits it, right? What's my highest y?
4.
Okay, now I want you to look at the previous domain and the previous range, what we started with. This is what we did. We went right 3, up 4. And how else could we have gotten the domain and the range, just knowing that information? Add 3 to the domain, right? If I added 3 to this and I added 3 to this, and then what did we add to the range?
4.
Add 4, yeah. So we could have found the domain and range that way. Okay, this next one is the same idea. I want you guys to tell me if we need to do that or not. Thumbs up if you're good and we don't need to see it. Can you give me a thumbs down if you're not good with this? So it's like, give me a thumbs up. Are you good with what we just did? Or a thumbs down if you're not, please. Okay. Then tell me just which way we would shift this. Let's just talk through that. Which way would we shift this if it's x plus 2 in parentheses? Left 2 and down 1. You'd go back to the original graph and you're going to pick this whole graph up. You're going to move it left 2, down 1. But I think it's easiest if you kind of just do each of these points. Move them left 2, down 1. And then kind of connect them the same way. Okay? So I think since most of you were good with that, let's finish these first, and then if we have time, we'll come back and do that one. Is that okay? All right. Let's go to this one, negative f of x. If it's, in essence, the y value that has the negative in front of it, how does that flip it? Yeah, so this is over the x-axis. Can we just abbreviate reflect over the x-axis? Okay, so we're going to flip this over the x-axis. That is this graph right here. Okay? So my x-axis is this horizontal axis. So where this was 1, 2, 3 below, it's now going to flip 3 above. That's at -5, right? So I flip from below up above. Okay, and then this goes all the way to here. If it's already on the x-axis and you're flipping it over the x-axis, what happens? Just stays there, right? So this is going to go to -2, and this was just a straight line there, right? So I'm going to do the straight line there. These points should correspond, and they do. Okay, now this one is down at 0, -2. When I flip it over the x-axis, it would go up here. This is what it looked like, the curve looked like below. So can you picture it flipped over the x-axis? Yeah, it's going to look like part of a little hill here. I would describe that as more like a little valley. Okay. And then, so we're right here. This down here is how many below? 1, 2, 3, 4 below. So it's going to be now 5 above. 4 above. Don't ask me why I added 1. Straight up. And then this guy is 3 below, so it's going to flip to 3 above. Okay, so you basically flip that, flipped it over the x-axis. Okay. What's the domain of this? What's the x furthest to the left, x furthest to the right? Aaron, can you tell me what the domain is?
-5, 3.
Okay. And what about the range? It's my lowest y.
-2 or 0, 4.
There you go. So what changed? What changed from the original domain and the original range? What changed? Yeah. The domain didn't change, right? Just the y values did, which makes sense because this is saying change the y values. So guess what's going to change on this next one? The x values. Because this reflects over the y-axis. So we're going to flip it horizontally, right to left. So what's a little tricky about this, you got to go back to this original graph. It's going to be kind of hard for me to show. So I'll have to slide it up and down here, okay? But I'm going to come over here. If I'm going to flip this over the y-axis, this point, since it's 1, 2, 3, 4, 5 to the left, it's now going to be 5 to the right. But it's still going to be down at -3. Okay? So I'm going to, at -3, I'm going to go 5 to the right. And then this point was 2 to the left of the y-axis. It's now going to be 2 to the right, but it's still going to be at 0. And there was a straight line that connected those two, so I'm just going to draw a straight line. Okay. Back here, if this is on the y-axis, it's not going to change, right? So 0, -2 is still going to be here, but then it's going to be the other side of that valley, or the other side of that U. It's going to look like this, flipping it around, right? And then just follow that same reasoning. At -4, it's over 2. Straight line there. Straight up. Is that what your graph's looking like? Have you guys ever done anything like this before? Reflecting kind of funny looking graphs like this? All right, can we do the domain and then we're done with this? Let's see, who have I not called on? Savannah, can you help me with the domain here?
It's 3 or -3, 5.
Brackets or parentheses?
Brackets.
Okay, and what about the range?
It'd be -4, 0.
Okay, so what ended up changing from the original here, -4, 0, the range stayed the same, but the sign and the values for the domain traded spots. Kind of interesting. All right, so your assignment, you guys, is to do in your packet worksheet 4. And so the front side is just like this. Is the notes are almost identical. Okay, so you can really use your notes for that. I also want to give you. Let me stop recording.